Okay, we have an architect who's designing an 8-story apartment building. It's going to be, when it's finished, 128 feet high. He made a model of the building using a now wait a minute, this is supposed to be 3/4 of an inch equals 1 foot. How high was the model? This is a ratio and proportion problem, and we're going to go just smaller to bigger. Is to smaller to bigger. So we have 3/4 of an inch is to 1 foot, which is the larger in the scale, is to, we don't know how large this model is. We're going to call it X, and we have 128. And when we cross multiply, we're going to get 1x, which is x. It's very convenient, which equals 3/4, which is 0.75 times. You know what? I'm going to leave that as 3/4. See how easy this is going to be. 3/4 of is 128 times 128. Put over 1 to avoid confusion. So you can see that 4, we're going to cancel that out. 4 goes into this, 4 goes into 12, 32 times. 4 goes into 12, 3, and then just goes into 4 goes into 8, 2 times. So our answer is 3 times 32, which is 96 inches. This brings up this next one here. They want to know, Oscar wants to draw a chord on a circle shown below. Where should he draw the line segment? Here's the chord. Goes from A to C. That's our line segment. That takes care of that one. Which line segments are perpendicular? If you look if we look at our test sheet, it's on page 10. This happens to be number 13. I drew this out. It doesn't exactly follow what we have on our test sheet, but I wanted to point something out to you that if you look on your test sheet, notice that when they talk about a perpendicular, they talk about that. They have a little square in the line. That where these two lines intersect, they're perpendicular because there's a right angle here, and the right angle equals 90 degrees. So we can say on this particular line, this particular set of line segments, that DC is perpendicular to AB. DC is perpendicular to BC, AB. And the reason, and if you look at your paper, you can see that, for example, this area and these lines are not perpendicular. I'm not drawing a right angle here. And when on your test booklet, you're going to see if they refer to two intersecting lines as being perpendicular to each other, you're going to see that little box written at the intersection point, which indicates to you that you're looking at a right angle and that those two intersecting lines are actually perpendicular to each other. Mr. Chang made two similar rectangular window frames. One frame was 12 feet wide and 16 feet long. What could the dimension of the other frame be? Well, just put this down as 12/16, and you can see that this is these are both divisible by 4, and we can make this equal to 3/4. And if you look at all of your answers here, they say 2 feet by 6 feet. That's one of them. 2 by 6. Well, this is 1/3. So that's not true. That's false. And another one that they gave you was 16 by 20. 16 by 20. I'm getting the ratio of these numbers. And 16 by 20 is the same as to 4/5. Well, 4/5 is not equal to 3/4. That's false. And another one that they gave you was 24 to 48. Well, that's 2 times 24. So the right answer here is 6 to 8. 6 to 8. Yeah, 6 to 8. That's 3/4. So this is true. Is this 3/4 and this 3/4? Look at that. Exactly the same. So that would be true. That's the one we're looking for. 6/8 would be the proper dimensions. Let's move on to this next one. Trapezoid QRST is congruent to trapezoid WXYZ. Which side corresponds to side TQ? Firstly, this word congruent, what it means is that, let me see if I can get this, fix this object here. I take this object, I can move it right on top of this object, and notice it's exactly the same. That's what congruency means. It means it's you can take one object and just overlap it right on top of the other object. So we are congruent. We just took the one on the right and put it on top of the one on the left, and it worked. So they're exactly the same. And what they're looking for is they say that this side TQ plus corresponds to side ZW. So it would be TQ equals ZW. And that's your answer. Which quadrant is this point located? We went over this earlier in the year. Quadrants is 4, this is 1, 2, and they write them in the Roman numerals, 3, and then 4. So this point is in quadrant 4. That's just checking to see if you know the definition of quadrant using an XY Cartesian coordinate system. And notice that these are labeled X and Y down there, okay? That's our Cartesian plane, XY plane. And it's broken up into 4 different quadrants, 1, 2, 3, 4, and they use Roman numerals.